All right, here's the last of the reflections worksheets in this series. Here, we're reflecting across the lines y equals x or y equals negative x. Let's start with y equals x. The line y equals x is the collection of all the points in the coordinate plane where the x coordinate equals or is the same as the y coordinate. So, for example, 1, 1 is on that line. So is 2, 2. Or 0, 0, or negative 1, negative 1. I think you can see what we're shaping up to get here. It's a line that runs diagonally through the grid at a 45-degree angle there. Like so. Except you could probably draw yours a little better than I drew mine. Now, when we're reflecting across this line, we can't count spaces. Like I wouldn't reflect. F is 1, 2, 3 spaces from the line, and so its reflection is 1, 2, 3 spaces down. That wouldn't be right. When you're counting spaces, you have to go straight to the line at a 90-degree angle. In this case, since this line is over 1, up 1, over 1, up 1, the line that runs to it perpendicularly, or orthogonally, or a fancy word there for you, goes down 1 over 1, down 1 over 1, and so on. Oh, man. Basically, we're counting diagonals of squares. So G here is one diagonal away from the line. Geez. So its image, G prime, is one diagonal away from the line in the other direction. And then we have F, which is 1.5 diagonals away. And so its reflected image, F prime, is a half, 1.5 away. Right here. D is 1, 2 diagonals away. So its reflected image is 1, 2 diagonals away in the other direction. D prime. And E is 1 diagonal away from the line. And so its reflected image is 1 diagonal away in the other direction. E prime. So we just have to kind of connect our 4 points as such. Okay. And you'll notice that they do overlap. That's perfectly okay. And we get kind of this butterfly sort of looking thing. All right? So that's a reflection across the line y equals x. Now we're going to reflect across the line y equals negative x. Well, it's a very similar line. In this case, it just crosses through the origin, heading downward at a 45-degree angle, like so. It happens to also be the collection of all the points where the x-coordinate is the opposite of the y-coordinate. So +1, -1, or -1, +1, so on. Same procedure. K is 1.5 diagonals away, so its reflected image is half, 1.5 on the other side, K prime. L is 1.5, so its reflected image is half, 1.5 in the other direction, that's L prime. M is 1, 2, 3.5, so half, 1.5, 2.5, 3.5. M prime, that far in the other direction, and then we just go ahead and connect our 3 points to form a triangle, and there's our reflected triangle, M prime, L prime, K prime. Okay, so I'll leave the rest of these up to you. On the back side, you're not going to spend a lot of time on this one, because here you just have to say what's the line that's being reflected across. Now, not all of these are x equals y, or y equals x, or y equals negative x. Some of these are just x equals something, it's a vertical line, or y equals something, a horizontal line. They might be an axis, all sorts of things on the back side here. So it's kind of a hodgepodge, but see if you can sort them out. Okay? Again, they're all just reflections across different lines, though. All right? Again, answer keys posted online, except for the one that I'll check for you, and you're all set.